Okay, if I'm going to graph the first one's already in this vertex form I need. So I'm going to establish what the vertex is. And this is where your graph paper now might come in handy. To find the vertex, I go inside the parentheses here. I notice that it's x minus 3. For my x-coordinate on the vertex, I'm going to make that a positive 3 because I'm just taking the opposite of whatever this number is. As far as the y-coordinate is concerned at that vertex, the y-coordinate is going to be the number that's on the outside here, that plus 4. Now, in addition to finding the vertex, let's find a couple of quick points here, some symmetrical points I can graph with. Talked about choosing values for x that surround the x-coordinate at the vertex. If I choose a value that is, say, 1 less and 1 greater, I'd choose 2 and 4. And if these are significant symmetrical points, I should notice when I take 2 and 4, plug back in up here, I get the same y values back for both. So take 2, plug in. 2 minus 3 get negative 1. Negative 1 squared is positive 1. 1 plus 4 get 5. The question becomes, if I plug in 4, do I also get 5 back? If I plug in 4, it's 4 minus 3, 1, 1 squared, 1 plus 4, yes I do. So if you know these are significant symmetrical values, if you plug in 1, get that y value, you automatically have the y value for the other. So let's plot these 3 points. Let's sketch this graph. Starting with the vertex, 3, 4. There's 3, 4. Symmetrical points were 2, 5 and 4, 5, right? For our purposes here today, that should suffice. So we sketch in our parabola. We've got our graph. Okay, using the same approach, if we do this third one, vertex. Going inside the parentheses here, I see x minus 4. I'm going to take the opposite of this value to make up the x-coordinate at the vertex, so that's going to be 4. The y-coordinate corresponds to whatever's added on out here. There's nothing added on out here, so y-coordinate 0. Setting up some symmetrical points. Since the x-coordinate was 4, choose a value that is 1 less and a value that is 1 greater than 4. So I choose 3 and 5. I take 3. I plug in for x to figure out y. So 3 minus 4 get negative 1. Negative 1 squared is 1, but then you have this minus in front, right? So that's going to make y negative 1. And since these are symmetrical points, I'd get the same thing back for when x is 5. So let's plot our vertex and our symmetrical points and form our parabola. So it was 4, 0 for the vertex. It was 3, negative 1, and 5, negative 1 for the symmetrical points. Looks like that's enough to play with. Let's go ahead and draw our curve.